Okay, Geometry AB, we're doing something a little bit weird today. We're actually going to go back and talk about the very first section in the entire book, which is section 1.1. And we didn't cover that section at the very beginning of the year when you would think that we probably should have, because it really doesn't make a whole lot of sense to me for where it was that they put it. In 1.1, we're talking about nets, which are basically another way to represent three-dimensional solids. And we weren't doing anything in chapter 1 involving three-dimensional figures. So I'm still a little bit puzzled as to why it was they chose to introduce this content at the very beginning of the year. Anyway, it applies pretty well to what we're doing here in chapter 11. So rather than diving into the second half of the chapter here on volume, I thought this would be a good thing to do to end our week here. So we're putting this in chapter 11, but it is section 1.1. So what they're doing here in this section is they start off by defining the word polyhedron right here, which is actually what we've been dealing with so far here in chapter 11 when we've been doing surface area. So a polyhedron is a three-dimensional solid whose surfaces are all going to be polygons. And that's what we've been dealing with a lot lately. Some of the examples we've been dealing with, we've been talking a lot about rectangular prisms. So if we were to draw ourselves a square, but then kind of make it three-dimensional, going back like this, all right, and there's a hidden line back here, and a hidden line back here, and a hidden line right here. That would be an example of a rectangular prism. Might even be a cube if you want to think about a die from a game like Monopoly or something like that. And what we have here is a three-dimensional solid. It's got both a length and a height, and it's got a depth to it as well. And the surfaces of that figure are all going to be polygons. Another one we've been talking about recently has been pyramids. And just to draw one that's a little bit weird, if we wanted to draw something like I don't know, let's see, 1, 2, 3, and then I'm going to draw some hidden lines here on the back, 4, 5, and 6, that is a poorly drawn hexagon right there. And if I put a vertex up here at the top and connected that vertex to each of the 6 vertices of the hexagonal base, which would be right about here and right about here, what we have there is a hexagonal pyramid. That's another example of a polyhedron right here, because what we just drew is a three-dimensional solid, and the surfaces are all polygons. In this particular figure here, we have a hexagon down on the bottom and then a bunch of triangles on the side. Now, a couple examples of things we've been dealing with lately that are not polyhedra, that'd be the plural of polyhedron. Let's see if we recognize this one right here. I just drew a circle on the top, another congruent and parallel circle down there on the bottom. This, hopefully we recognize, is what a cylinder looks like. But a cylinder is not an example of a polyhedron. It is a three-dimensional solid, but the key word here is that all of the surfaces in a polyhedron have to be polygons. And a cylinder has circles here on the top and down here on the bottom, and circles are not polygons. So a cylinder is not an example of a polyhedron. But prisms and pyramids are going to be excellent examples of polyhedra. All right, there are others, but those are the ones that we're going to see most prominently. Okay, so let's move on right here. Parts of polyhedra, all right? There are basically 3 components that make up every one of them, and those are going to be the faces and the vertices and the edges of your polyhedron. So let's draw ourselves something right here. I'm going to stick with black right now, and then we'll do some color in here a little bit later. And I think what we're going to draw this time, an example we've messed with a little bit, I'm going to draw a triangle, albeit at kind of a slant right here. And we'll go ahead and say that that one right there is going to be a right angle. Okay? All right, so with that in mind, and then I'm going to draw the rest of this thing kind of shooting back in this direction here, like that, and this line is going to be hidden. All right, and if I draw some dotted lines here and here, and then connect it like that, okay, everybody, what we have right there is a triangular prism. Okay, going back to some definitions that we've talked about earlier in the chapter, it's a prism because it has 2 congruent and parallel polygon bases on opposite sides of the figure. There's a triangle here on the left and a congruent and parallel triangle over here on the right. So those 2 triangles that I just shaded in yellow right there, those would represent the 2 bases of this figure. And then connecting those bases, switch colors right here, connecting those bases, we have a rectangle located right here. There's another rectangle on the back of this figure that goes here, and a third rectangle that makes up the bottom of the entire figure. So when we have two congruent and parallel polygons on opposite sides of the figure, like our triangles, and those polygons are connected by rectangles, like we have here, that's the definition of a prism. All right, let me get rid of all of my markings right here because that's going to confuse what we want to do here in just a second. Okay, so let's start talking about a few different things here. I'm actually going to start with vertices right here, and the vertices are the points where all of the different line segments in this figure come together. So using red right here, I'm just going to make a little dot everywhere that line segments come together. Now this triangle on the left has three sides. That means it has three vertices as well. So 1, 2, and 3 vertices on the left side. As we look at the triangle on the right, we have the exact same 3 vertices here in that spot. And that should be it. So in this particular prism, we ended up with a total of 6 vertices. Now that's going to be different in every polygon or every polyhedron that we look at. For example, if we went back to the rectangular prism here, looks like I've got 1, 2, 3, 4, 5, 6, 7, 8 vertices right there. For my pyramid, 1, 2, 3, 4, 5, and 6 on the base, and then 1 up here on the top. So that's going to change on every polyhedron that we look at. But in this particular example of our triangular prism, we have 6 vertices. All right, let's switch colors again here. We're going to go blue now, and now we're going to start talking about the edges. And the edges are simply going to be the line segments that make up this figure. And what I'm going to do here now is basically just retrace all of the line segments that I drew initially. So, starting with the triangle, we had 1, 2, 3 edges here on the left. The other triangle on the right gives us 4, 5, and 6 on the right. And then connecting those two triangles, we have a 7, an 8, that's dotted back here, and a 9 as well. So this particular figure has 9 edges to it. Going backwards right here, let's take a look at where we're at here. In the prism that we had, we have 1, 2, 3, 4 on the top, 5, 6, 7, 8 on the bottom, 9, 10, 11, and 12 connecting them. In the pyramid, if we were counting edges, 1, 2, 3, 4, 5, and 6 on the bottom. And then going up to the top, 7, 8, 9, 10. There's an 11th, and here's a 12th going right back there. So again, that's going to change in every problem that we do. And the last one I wanted to talk about, we're going to go back and use the highlighter for, was going to be on faces. And faces are the toughest one to draw right here because faces are basically going to be the planes or the polygons that make up this figure itself. And so when we look at what's going on in this figure, we said that we had one polygon or one plane as our triangle over here. So one triangle on the left and a matching congruent and parallel triangle over here on the right. That's 2. And then when we looked at the lateral faces, the rectangles connecting them, there was one on the back side of this figure right here, so that's 3. One on the bottom, so that's 4. And then we had this big one here on the top, and that was going to be a 5. So the number of faces we were going to end up in this figure was going to be 5. Now the reason I'm writing those numbers down, it's important and it comes into play a little bit later, but we'll kind of leave it at that for right now.